Answer key. Here we go. So 10D number 2, sketch the following curves and then find the coordinates of where the derivative would be 0. All you need to do here is quite literally make Desmos or your calculator sketch them. So let's do that. Okay, cool. Here's the first one. 3x squared minus 6x, or 3x cubed minus 6x squared plus 15x. You can see it. It's right there. I'm super sorry. Words. This is what it looks like, and it says, hence, find the coordinates of where the derivative would be equal to 0. You're just looking for a maximum or a minimum. And if you want the actual coordinates, what you can do is just ask Desmos to tell you what the max and the min are there. The other thing you can do is you can actually calculate the derivative and set it equal to 0. So in this case, what that would look like is you'd say dy dx is 9x squared minus 12x minus 15, and then set that equal to 0. But you don't have to do that for this problem. It's just saying, like, identify where the derivative is equal to 0, which is here and here, and then find the coordinates. You can guesstimate them for us here, or you could actually make Desmos tell you what they are. Here I made Desmos tell me. So I went back and I just actually asked Desmos what those coordinates are, and you would tell me this is a max, you would tell me this is a min. Okay, so the other graphs, part B here, this is that function, and you have a minimum here at 2 and a maximum here at x equals 0. You could plug again those in to get those coordinates. And over here, it says x e to the x for when x is more than 0. And because this guy's just going to shoot off into infinity, there is nowhere over here that you're going to get a slope of 0, so there is no solution for C. The solutions for B would be 0, -1, and 2, 3. Let me know if you have questions. But don't overthink this one. You're just basically identifying minimums and maximums by looking at the graph. Okay, part 4 is basically just a graphing maximum problem. So here's what we're going to do. We've got this business, it's buying engine parts. There are 3 different models for each of the strategies, and each of them, P, or this is where our Y is going to be expected profit in thousands of euros, and N, that's our X value. So if you want to like mark that, the like P, this is your Y, and N, this is your X. You could do that. Parts per thousand. The largest number of parts the factory can sell is 5,000, and there is no minimum. So they could purchase down here between 0 and 5. So if you want to, you could even like draw yourself a little line here at 5. That's super bad, but like everything over here doesn't count because that's the maximum number of parts that we could purchase. Okay, and then these are the 3 different models, which I have typed in over here. I know they kind of cut off over there, but I promise I typed them in. So for each of them, we're going to find the maximum profit. So if you're looking at this first one, so AI, that's the black curve. We're looking for where is the maximum profit that we could possibly get between 0 and 5. And looking at that, it sure looks to me like buying nothing gives me more profit than doing anything else here. So that's probably where I'd sit. Which doesn't make much sense, but we know that the book is stupid, so let's not linger too much on that. For the second one, that's the red one. Here, obviously there's like kind of a maximum happening here, but then it goes far more maximum. And so the real maximum is happening right at cutting off. So if I buy 5,000 parts, that's going to be my best deal here. And then the blue one, which I have here, it's got a maximum probably somewhere sitting around 4,000 parts if I actually looked for it. So for each model, finding the maximum, let's actually write down what those are. Okay. I went back in and I just, you can't see it quite here, but if you type into Desmos like a range, like 0 less than x less than 5, I put that restriction on all of them, so it's only showing me the x between 0 and 5. Cool. A of 0, which is our biggest one here, would be 5.5. b of 5, so that's this red one. The reddest is high at x equals 5. And then c is actually highest at x equals 4, which is right there, so 4.6. So based on these, we're saying the maximum profit. These are the maximum profits for each of the models, A, B, and C. And then which strategy should they adopt? Because the book is incredibly stupid and has lots and lots of mistakes, clearly you should not buy anything and you should go with Model A, because that is the highest number that we've got here. If you get rid of Model A, which probably is incorrect, I bet if I check the online textbook, it'll be different than yours. You probably want to go with purchasing 5,000 parts and using Model B, because that is higher at least than Model C. Let me know what questions you have. Okay, we've got our classic garden problem here. We got a vegetable garden. We have 100 meters of fencing. So just imagine that you have like literally pieces of fence that sum to 100 meters lying around. So you could theoretically make one that is like 10 meters this way and 40 meters this way. And then you'd have another 10 here and 40 meters here. That is one option for you. You could do 25 all the way around. 25, 25, 25, 25. You could make a really stupid looking one, but maybe you have like a long piece of land, whatever, that's like 1 meter here and 99 meters here. 1 meter, 99. All of these are options for you. And this is basically, we've got like a circumference or a perimeter that is then playing with area. Because obviously, if I'm trying to maximize garden area, I want to have a bigger like section in here where I can plant things. So just looking at this, you might see some of these look better than others, and some of them are kind of silly. So expression for length. Basically, I'm saying if, here's my fence, if this is X meters here, this is going to be 50 minus X meters. Hopefully that makes sense as you kind of look at these, because if I'm going to have a sum of 100 and it's going to be a rectangle, half of that rectangle has to be 50. So hopefully that's okay. So this is the expression for length. Highlighting expression for length. Cool. So then area, you don't really have to show much here. It's just that if I wanted this area on the inside, you would hopefully tell me that it is going to be x times 50 minus x. Okay, so that's a. So find the derivative of a with respect to x. So if a equals x 50 minus x, we're going to find the derivative. So I'm going to distribute this, 50x minus x squared. That's still a. And then a prime is going to be 50 minus 2x. Just the derivative, like derivative of 50x is 50. The 2 comes down and multiplies. There we go. And then it says, find the maximum area of the garden and the corresponding dimensions that give that area. In calculus, the way that we would go about that is this guy right here is a parabola, and it's going to have 50 here and a 0 here, and it's going to be upside down. It's going to go like, kind of like that, where this is going to be our width, and this is going to be our area. Okay. The reason that we'd actually find the derivative is if you actually graph that and solve for where that is equal to 0. So 0 equals 50 minus 2x. 2x is equal to 50. Yep. And then x is equal to 25. At x equals 25, that's where our derivative is going to be 0. And notice, I've got positive slope here and then negative slope, so I know that it's going to do something kind of like that. That's my derivative, so this is like a prime if this is my a function. Cool. That means that the maximum is right here at x equals 25. and that means that this square is actually my best garden. This is going to be the most area for 100 meters of fence. Let me know what questions you've got. Okay, so we're starting out with this card that is 20 by 24, and then it says equal squares of side X centimeters are cut out of each corner. So what that looks like is like we've got a little corner here and here and here and here, and we're going to get rid of all of that. So that's like gonzo. I should use a scribble as opposed to. And each of these we're saying is a square that is X by X. And then what they're going to do is they're going to kind of like fold here, fold here, fold here, fold here, and then they're going to fold it into a box where they've just like taken each of these flaps and kind of folded them up. So you'll end up with a box kind of like this. That means that the height of the box is going to be X. This distance right here is going to match up with that distance right there is going to match up with that distance right there. And so that would be 20 minus 2x is going to be that length. And then this, what color should I make? We'll make it green. Nope, you guys can't see green. We'll make it orange. Nope, that's too much. Oh, we'll make it purple. This distance right here is going to match up with this distance right here. And that is going to be my 24 minus 2x. So 24 minus 2x. Okay, volume is just length, width times height. So what we're going to do to show this function right here is multiply these. Multiply, 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 distribute, and you're going to get this guy. So that's part A. Find the derivative. So we're going to say this is my v. So dv dx is going to be 12x squared minus 88 times 2, that would be 160 plus 16, so 176, x plus 480. Find the value of x for which dv of x equals 0. So what I'm going to do, because you guys can use a calculator at any point, is I'm going to use a calculator to do this, because that seems annoying to do by hand. Okay, so values for which the derivative is equal to 0. So here's my derivative, here's my original function. Where that is equal to 0, I asked my calculator, and it is that x equals 3.6 and x equals 11.45. And then it says verify the global maximum does not occur at the endpoints of the domain. So what's the domain going to be like on this one? Well, if you go back to your lovely little box here, what are the possible squares that I could cut out? Well, I could not cut anything out and I'd get a flat piece of paper. Or I could cut all the way up to 10 centimeters out on each side, right? If I cut 10, it would be like 10. It's just that it would also be like cut out 10. So I'd cut out this and I'd cut out this, and that would make a not great box because you would literally have no area in the center. But you could do it. It just wouldn't be a great box. You just kind of fold this middle bit up as a flap. So 10 is really the largest value that I could get here. So answers over here, and notice that's where my V area hits 0 at 10 right there. So obviously I'm not going to use that one. So it says verify that the maximum, that's the maximum, don't happen at the endpoints of the domain. They just want to make sure that between x is 0 and x is 10, that's not necessarily the maximum of my function. And it's not, so we're good. Cool. And then the last bit is hence find the maximum volume of the box. And really, the maximum volume is going to happen there, and using my derivative, right, because figuring out what that is kind of hard to calculate, but using the derivative, if you set this guy equal to 0 and solve, one of your solutions is going to be 3.6, and that is the maximum value. So if we plug 3.6 back into this original volume function, we get approximately 774 centimeters cubed, and that's like this guy up here. Cool. Well, let me know what questions you have. Okay, so this now in 10F, we're talking chain rule. And first thing that they want you to do is just figure out what the inside and outside functions are. So like for A, I would call u of x, sorry, let's go y of u, that would be u cubed. And then u of x would be x squared plus 4, and that is just because like the outside function here is something cubed or u cubed. And then to get the derivative, what we're going to do is we're going to get dy du, which is 3u squared, du dx, which is going to be just 2x. And then if you go look at your chain rule, dy dx is dy du times du dx. So we're just going to multiply, oh come on, 3, wrong thing, 3u squared times 2x, and then u we're going to replace with 3 times x squared plus 4 squared times 2x. The simplified version of that would be 6x x squared plus 4 squared. That's my dy. Actually, why is it asking for dy du? That's so lame. I guess it's just this. I think they really wanted du dx. Silly book. Either way, so I'm going to solve these for dy dx. I don't know why they're saying dy du. I only asked for a, c, and e, so let's clear this out of the way, and then we'll get c and e. Okay, for c, our outer function here is going to be y of u will get us 2u to the 4th, and then u of x would get us x cubed minus 3x squared. I'm again going to solve this for dy dx, so I'm going to get the derivative of both. So dy du is going to be 8x cubed, du dx is going to be 3x squared minus 6x, and then, oh, sorry, silly Perkins, this is a u, and then we'd get 8 times u cubed times 3x squared minus 6x, and then u, because this is a u right here, I'm just going to plug in x cubed minus 3x squared. This is dy dx. If you want to get technical about it though, here's your dy du for what they were asking. You can still, again, simplify some of this. You'd have to do a lot of distributing though, so I would probably leave it like that. Your call. Last one, I'm just going to do it down here. Y equals 1 over x squared plus 1 squared. I would probably rewrite this pretty quickly to make this x squared plus 1 to the negative 2. I think that just makes it a little bit easier then. And I would write this as y of u is going to be u to the negative 2, and then u is 2, or x squared plus 1, u of x. Then dy du equals negative 2 u to the negative 3, du dx is 2x, and then we're just multiplying. So negative 2 times u, which is, of course, x squared plus 1 times 2x. This is dy dx. But if you want to be technical, I guess they asked for this one. Silly people. Let me know what questions you have. Okay, very last question. B, C, and E, find the derivative. So we're just going to take these one at a time. B, I will do in purple. So we've got g of x is 6 times 5x plus 2 to the 1/3. I'm going to write this as g of u is going to be 6u to the 1/3. U of x is going to be 5x plus 2. y du. I didn't even use a y, but that's okay. And then du dx is going to be, we're going to get 6 times a third, which is 2. U, and then if I subtract it, I'm going to get negative 2/3. And this is going to be 5. And then dy dx is going to be 2 times u, which I'm just going to plug in right away. 5x plus 2 to the negative 2/3 times 5. If you are somebody who just really likes rewriting stuff, absolutely fine. Dy dx is going to be 10 over, because that negative is going to put this under, so the 10 comes from 5 times 2. And then it's going to be negative, and then cube root of this thing squared. So it would be the cube root of 5x plus 2 squared. Absolutely not necessary to rewrite these. They're the same thing. This thing and this thing are totally the same. But if you want to, you can. Okay. C, I'll do over here, is h of x equals the square root of x minus 4 cubed. I'd rewrite that pretty quickly and say that that's y equals u cubed and u equals x to the 1/2 minus 4. And I'm only doing that because I don't want to deal with the square roots, so I'm going to treat it like a half. Dy du is going to be 3u squared. Du dx is 1/2 x to the negative 1/2, and that 4 will disappear. Then dy dx is going to be 3 times the square root of x minus 4 squared times 1/2 x to the negative 1/2. And if you would like to rewrite that, you don't have to, but if you would like to rewrite that, you could write that as dy dx is equal to the 3 and the 1/2 can multiply. So you just get 3 halves. This part will remain in the numerator, and this will go to the denominator. So you'd get square root of x minus 4 over square root of x. Okay, let me know questions. Last part is E, which is 4 over 5t minus 1. Y equals 4 over 5t minus 1, which is the same as 4 times 5t minus 1 to the negative 1. I'm going to write this as y equals 4u to the negative 1, and u equals 5t minus 1. dy du is going to be negative 4u to the negative 2. du dt this time, because we just have a t, it's going to be 5. And then we're going to multiply them together. dy dx is going to be negative 4 times u, which is 5t minus 1 to the negative 2, all times 5. So we'd get, if you want to rewrite this, negative 20 over 5t minus 1 squared. Let me know what questions you have. I know that was quick, but hopefully it made sense.